Now I would like to explain the mechanism of free radical polymerization. The free radical polymerization consisting three steps. Number one is chain initiation step, chain propagation and chain termination. Chain initiation step. In this step, some molecules like benzoyl peroxide are acting as starting materials, and they are very preliminary materials for chain initiation step. And benzoyl peroxide undergo the reaction with heat. Then here the benzene ring C double bond O and bond O, and this O bond O is peroxide bond. This peroxide bond undergo cleavage, and the conversion of benzoyl free radical takes place. The benzoyl peroxide is one of the very best example for chain initiator, and in this step we can observe the formation of two free radicals, benzoyl free radicals. And one more example is there, that is azobase isobutyl nitrile, and this one is example enough, and this benzoyl peroxide example is enough for us. And you may remember the benzoyl peroxide is used as chain initiator. And the second step, that is the chain propagation step. In this chain propagation step, here the R dot is nothing but the free radical, that is a benzoyl free radical, and the CH2 double bond CHX. This is the example of a monomer unit. When the free radical reacts with monomer unit, then there will be a formation of bond between this free radical to monomer unit. Then this is the final product. And continuously in chain propagation, one more monomer unit reacts with the obtained free radical. Then further the chain will continue up to n number, and this step is known as chain propagation step. And the third step is chain termination step. Termination is nothing but the reaction will come to an end. So the chain termination will undergo many processes. The process number one is, in this step the two monomer free radical units reacts together to form a final molecule where we cannot observe the free radical. That is one process. And another process is one monomer free radical, and another one is chain initiator. Chain initiator, and more particularly the free radical inhibitor, we can say. And in this is free radical inhibitor. Generally the hydroquinone, nitrobenzene, oxygen and phenol and amines are using as the free radical inhibitors. And this R dot reacts with monomer unit, and there will be a formation of final product. And this is one process. And another process is the disproportionation of the free radicals. And in this process, the hydrogen atom which is present in one monomer unit shifted to another monomer unit. Say for example CH2, here one bonding is there, CH2 single bond CH and one X. This X may be chlorine, bromine, iodine, etc. And this is free radical. So this is one monomer free radical and another monomer free radical. So here what happens, the hydrogen atom shifted. So from the hydrogen atom from this monomer unit shifted to this monomer unit. See here, this hydrogen molecule shifted to here. Then here the one molecule is CH2CH and bonding, and here one hydrogen is shifted, no, then the one electron which is present in between the carbon and that hydrogen will come to here and they will form a double bond. So in this case the final molecules are, one is saturated molecule and another one is unsaturated molecule. So like this we can go for the chain termination step. So in this free radical mechanism we have chain initiation, chain propagation and chain termination step. Now in our syllabus we have plastics. So in plastics, two or three examples are there. One is polyvinyl chloride, another one is the Bakelite. You know, polyvinyl chloride is example for thermoplastic and Bakelite is example for thermosetting. So in this case, regarding plastics, the polyvinyl chloride is the best example and it is example for thermoplastic and in this case we have to study how to prepare the polyvinyl chloride and what are the properties and what are the applications. So here you have the reaction vinyl chloride. So simply you can say the preparation of the polyvinyl chloride. The CH2 double bond CHCl. It is vinyl chloride. And n number of vinyl chloride molecules undergo polymerization reaction, then we will get polyvinyl chloride. This is addition polymerization reaction. So the double bond converted into single bond and there will be a n in number. So this is vinyl chloride and this is polyvinyl chloride. This is the way of preparation and it is example for addition polymerization also. And see the properties. The polyvinyl chloride having some properties, some physical and chemical properties. It is colorless, odorless and non-inflammable and chemically inert in nature. This is one property. Another property is it is resistance to light and atmospheric oxygen, some inorganic acids and alkalis. And it is insoluble in hot chlorinated hydrocarbons such as ethyl chloride. So it is a very insoluble in ethyl chloride. Ethyl chloride is example for the hydrocarbon, particularly chlorinated hydrocarbon, and it has the melting point that is 148 degrees centigrade and has greater stiffness and rigidity. These are the some properties, physical and chemical properties, and we need to study about some applications also. So applications we can study under two categories. Generally the plastics are polyvinyl chlorides are two types. One is rigid polyvinyl chloride. These are called as unplasticized polyvinyl chloride. Another one is plasticized polyvinyl chloride. There is a difference between unplasticized polyvinyl chloride and the plasticized polyvinyl chloride. The difference is the plasticized polyvinyl chloride where we are adding some plasticizers such as dibutyl phthalate, dioctyl phthalate, tricrysyl phosphate. These are examples of some plasticizers. If we add plasticizers, then it will become plasticized PVC. If we are not adding, then it is unplasticized PVC. So in applications we have to write plasticized and unplasticized PVC. And first of all the plasticized PVC, and the plasticized PVC, it is superior chemical resistance and high rigidity, but it is a brittle. And The unplasticized PVC is used for making sheets and making the tank linings, light fittings, safety helmets, and refrigerator components, cycle and motorcycle mudguards. And unplasticized PVC is also useful uh, in place of non-ferrous metals. And regarding the plasticized PVC, some applications are there, and these are used to making container sheets employed for packing and for preparation of raincoats and for preparation of tablecloths, curtains, etc. And the plasticized PVC is also useful in preparation of electric cables. So these are some applications of the unplasticized PVC and plasticized PVC. And the second example in plastics is the Bakelite. You know, the Bakelite is one of the best example for thermo settings. Example for thermo settings. Best example for thermosetting polymers or thermosetting resins. So first of all, how to prepare the thermosetting polymer? The Bakelite is also called as phenol formaldehyde resin. Phenol formaldehyde resin. Why we are calling phenol formaldehyde resin? See, in this case, the phenol and formaldehyde, these two are starting materials. That's why this resin or this polymer is called as phenol formaldehyde. This is phenol and this is formaldehyde. When these two reacts together, and there will be a formation of ortho product and formation of para product and formation of 2,4,6 trihydroxymethyl phenol product. And ortho product is it is a very convenient for further reactions, so that the ortho product will undergo further reactions. Here you see, further the reaction will takes place in between the two ortho products. This is called as orthohydroxymethyl phenol and parahydroxymethyl phenol and 2,4,6 trihydroxymethyl phenol. And here you say the ortho product molecules will undergo reaction, and this is the orthohydroxymethyl phenol. And when two orthohydroxymethyl phenols reacts together, and there will be a elimination of the water molecules. And here in each and every, the benzene carbon is having one hydrogen, and this hydrogen and this OH reacts together and it is eliminated as a water. Like that, n number of ortho molecules reacts together to form a water molecule. So n number of water molecules will eliminate and there will be a formation of bondings. So this structure is known as novolac, NOVOLAC. After elimination of the water molecules, the obtained structure is known as novolac. And this novolac molecule will undergo reaction with the hexamethylene tetraamine compound, and there will be a cross-linked structured molecule like this. So when novolac molecule reacts with the hexamethylene tetraamine compound, and there will be a formation of the molecule called a three-dimensional cross-linked structure molecule, that is called as Bakelite. That is called as Bakelite. And this Bakelite is having some properties and having some applications. Now let me focus on the properties. Bakelite, it is a example for thermosetting, and it is having the qualification like a rigid, hard, and it is having high resistance and infusible and water resistant, and it is insoluble solid which is resistant to non-oxidizing acids, salts, and many organic solvents. In the very beginning, I explained about the differences between the thermoplastics and thermosettings, where thermoplastics will dissolve in suitable solvents, but thermosettings are not dissolving in a suitable solvents. That's why you remember the thermosetting is a very rigid, hard substance, and it is not soluble in the solvents and not soluble in acids, salts, and etc. That is one physical property. And another property is it is attacked by alkalis because of the presence of free hydroxyl group in their structure. Say, if you carefully say, the structure is consisting the free hydroxyl group, means OH group. That's why it will attacked by alkali molecules. And third point is it possesses the excellent electrical insulating character. Excellent electrical insulating character. That's why Bakelite is using in the switchboards and aircraft materials and other aerospace vehicles, etc. And applications, you see, in applications clearly they mentioned the thermosettings, particularly the bakelite, is used for making electric insulator parts like switches, plugs, switchboards, heater, handles, etc. And for making molded articles like telephone parts, cabinets for radio and television, and for impregnating fabrics, wood, and paper. And these are used as adhesives for grinding wheels and in paints and varnishes, and as a hydrogen exchanger resin in water softening, and these are used for making bearing used in propeller shafts and the paper industry and rolling mills, etc. So these are the properties and applications of the bakelite.